Okay.
It's a great honor for me to welcome Professor John Coffey from the University of West Florida. Close by, he will give us a keynote address on concept mapping and knowledge modeling, a multidisciplinary information and communication technology. A short bio: Dr. John Coffey holds a Bachelor in Science in Psychology, a Bachelor of Science in System Science, and a Master in Computer Science and Software Engineering. He was one of the first members of the Institute for Human and Machine Cognition, and he has worked with that organization for many years. He has been in the Department of Computer Science at the University of West Florida, and he has published more than 100 articles in highly renowned refereed journals, book chapters, technical reports, and also conference proceedings. It's a great honor that we have you here. His research interests include the sites of knowledge, elicitation, representation, web services, SOA, service-oriented architectures, and one of the hot topics of that conference, education.
Yes.
Welcome.
Thank you very much. Thank you very much, folks. I was sitting back there and somewhat amused at the lack of agreement between concept mapping and knowledge modeling as a multidisciplinary educational technology. Actually, they are two parts of the same thing. Concept maps are part of the knowledge model. So I guess this sentence is grammatically correct on a technicality. Overview of my talk: I'd like to introduce the problem that I hope to address. I'd like to talk to you generally about graphical representations of knowledge, uses of concept maps and knowledge models in educational contexts, for the capture and preservation of institutional memory or knowledge of other sorts, for knowledge generation or brainstorming generally, uses for documentation, for generating knowledge formalisms. Concept maps are very, very distinctly and proudly informal, but they can be used as a factor in creating knowledge formalisms. And then I'll conclude with a summary and some conclusions. So I wanted to start by showing you a concept map. I'd be quite curious to know how many among you know what concept maps are, by a show of hands. Okay, very few. Concept maps are essentially graphical representations of knowledge that are comprised of triples. So you can see concept maps represent organized knowledge. Organized knowledge is comprised of concepts. Organized knowledge is comprised of propositions. Concepts connect using linking words. Linking words are used to form propositions. So they read propositionally, but they are informal in the sense that they are completely unconstrained with regard to the vocabulary that can be used for the concepts themselves or for the linking phrases. The idea of a knowledge model, as we have constituted it at the Institute for Human and Machine Cognition, is like this. We can hierarchically organize concept maps. So you can see here, this one pertains to Gulf Coast region weather forecasting. Here we have, and I'm sorry this is so small, hard to read in the back, but this is a node or a concept that reads seasonal climatology. It can be expanded to have a map that gives particulars pertaining to this detail in a higher level map. So our knowledge models are hierarchically structured from a very general subsuming top level map to more detailed maps at lower levels. Furthermore, you will notice that many of the concepts have these icons beneath them. Those are links to accompanying resources that help to elaborate the concept that we're considering. So for instance, there was a textual description of climatology in the Gulf Coast region. This popped up when we clicked the text icon. We can have graphics. We could have a real-time satellite feed that would tell us what was going on with the weather. So I just wanted to get those out of the way very early. That's what a concept map is. That's the way we consider knowledge models at IHMC. I've talked about them for all of these various uses. And then the motivation for this work is that we all know, and I'm preaching to the choir, that with pervasive computerization and internet access, we've seen an explosive growth in the amount of knowledge that is available It is interesting to me that in decades past, when we had more unified interfaces, I'm thinking of earlier Mac OS, that in fact we really had relatively reliable ways of accessing functionality within computer programs and such. Now with the internet and interfaces all over the place, all bets are off on where we will find information and how we will access it. The average person is clearly immersed in an amazing amount of data, information, opinion, and knowledge. So we were looking for new strategies to try to address the creation, organization, and presentation of knowledge. And one of these answers that we found was in the use of concept maps structured into knowledge models. There are a lot of graphical or pictorial representations of knowledge. I always like the idea of a picture is worth 1,000 words. It's at least worth 1,000 poorly chosen words. Beyond that, I don't know. But pictorial or graphical representations of knowledge can be, not necessarily, but might be more concise, less ambiguous, and easier to understand than text. I'm always struck by people who underline their textbooks. You know, you get if you want an interesting experience, get a student's textbook and see what they underline. And you'll find that it generally is that they underline absolutely everything, which conveys no meaning at all, or they will pick out quite sparse nouns and verbs. And really the meaning is conveyed pretty well through those relatively sparse underlinings. It's just a question that all the other stuff is semantic or syntactic fluff that doesn't really need to be there. And graphical representations of knowledge cut through all of that fluff. And that is one of the reasons why they're very useful. There are a great many pictorial representations. It seems sort of remiss on my part as a computer scientist not to have included UML, which are diagrammatic representations of software. But I talked today about concept maps, mind maps, semantic networks as a few examples. So here's a mind map due to Buzan and Buzan. This one happens to be on presenting data, and they have over here graphs, bar charts, different types, stem and leaf, things that you'll recognize if you enjoy statistics. Here we have, well, maybe we might represent data in tables. We might represent summary data. You'll notice this kind of shifts gears because this was about representation. This is about a table. This is about the types of data that we have, right? So it could be quantitative or qualitative. This is just the type of data we might represent. That's how we represent it. The interesting thing about mind maps is they do not have explicit linking phrases. So the user has to infer what are the relationships among all these things. Particularly, graphs are a way of presenting data. This is a means. This is the type of data we would represent. But that is not captured due to the lack of linking phrases. This semantic network, by the way, there are a lot of things called semantic networks, some highly formalized as a knowledge representation scheme in artificial intelligence. This one less formal. But I read again up here, a marketing manager keeps written list of jobs staff are doing. Better sharing of information between executives. Clearly, again, one has to infer, well, a consequence of doing this might be this. But again, there is no explicit indication of what that relationship is. Increased morale or decreased morale, again, another implication, but we have to infer that, and our implications may be quite different than someone else's. Concept maps make all of the relationships, at least insofar as the creator of the map sees them, explicit, and that is one of their great powers. So I mentioned that I would convey to you a number of different uses for these. The first would be educational uses. I'd mentioned that Joseph D. Novak, a decades-long friend and colleague of mine, now emeritus professor of biology at Cornell, created these. And interestingly, he wanted to know misapprehensions that his biology students had. He was looking for a very particular problem to solve, and that was, how can I figure out what my bio students are getting wrong? And so he wanted to see a way to represent structural knowledge with its interrelationships, and then to be able to say, okay, well, these two concepts, yep, they belong there, but you really have the relationship between them incorrect. Or you've omitted this concept, or you've added this and it's not really relevant to this knowledge domain. Right? He soon realized that concept maps provide a really good means to externalize structural knowledge generally, so that it could be made and used by students in order to examine critically what they knew about a knowledge domain. And in fact, he has some lovely examples of a second grader who made a map about living things and how it evolved from this little simple kind of linear thing with 4 or 5 concepts into a concept map literally with 60 or 80 or 100 concepts, all very, very richly interconnected some number of years later. Various means in which they're used include having students create concept maps from scratch, creating concept maps from skeleton maps. A skeleton concept map means you give the map creator a little minimal concept map with maybe 3 or 4 or 5 nodes, and then they are asked to elaborate on it to fill in details. Another use is to create a concept map, remove the linking phrases, and ask students then to provide the linking phrases back, right, as a means of gauging how deeply they understand the interrelationships among concepts. By the way, underlying all of this, and I have no time for it today, is Alzabel's assimilation theory, in which Alzabel posits that one builds new knowledge by adding into existing knowledge structures. That is the way meaningful learning takes place. Contrasted with rote learning, where you give a person a bunch of stuff to learn, they go out and they learn a bunch of definitions, but they don't really know how the things they can define interrelate. So one of the fundamental ideas underlying concept maps is the idea of being able to foster meaningful learning in educational contexts. Oh, and finally, we might actually provide a complete concept map to a student as what is called an advanced organizer. Another idea from Alzabel's assimilation theory is that it is very helpful for students to give them a global structural view of the knowledge that you are hoping for them to master. And then again, they fill in the details of all of the particulars. So this is a concept map that I actually use in an Intro Java course that I teach. And this is actually the review for one of the exams. And you can see here Java programs have control constructs. They're described by Bowman Jacopini, some mathematicians who proved mathematical characteristics of computer programs, that in fact all programs need are sequences, selection, iteration. Sequence is an implicit construct. It doesn't have any grammatical elements in a programming language. It's just a bunch of statements in a row. Selection and iteration do have specific syntactic elements. They are if, else, and switch for selectors. They are for, do, while, and while for iterators. And we could work on the other side of this, but it's the same general idea. Knowing how to use that, that is an advanced organizer in the sense that it is all of the concepts that they need to know to be able to do well. But then the part that they have to provide beyond that is the ability to utilize all these things actually to create Java programs. With regard to knowledge modeling, I showed you that knowledge model when we started, and that's the fundamental idea I want to tease out now. So we can use concept maps first to capture, preserve, and share expert knowledge, and we've originated an interactive knowledge elicitation scheme at IMCIC. Typically involves having the subject matter expert, the person we will interview, to try to capture knowledge. We'll have an interviewer who keeps a dialogue going with the subject matter expert, and we'll have a knowledge engineer or recorder who actually can build the concept map as a session proceeds. It is an iterative process based on concept maps, and I'll tell you about that in just a moment. I am so sorry that this graphic is so small. I tried to get it as large as I could. Oops. Because I'd like to point out a couple of things. First of all, this is our subject matter expert here, tentatively looking at the concept map. Here is the interviewer. Here is the fellow who is actually working a computer, evolving the concept map as the session unfolds. You can see just very faintly up there in the top left, you can see it looks like a little sentence of words. My apologies again, it is so small. That is actually a focus question. So we will pose a question to be answered by the knowledge elicitation session. Help us keep on track. You can see that this looks like sort of a little clump of concepts linked together. Here's another clump of them. Here's another. Generally, creating concept maps is a bottom-up process that starts by laying out all of the concepts that we want, and then, as I say, building bottom-up by linking them together until they coalesce to form a complete concept map. You can see over here on the right, it looks like just 1, 2, 3, 4, 5, 6 individual concepts that have not been linked in at all. Those are just ones to which the session hasn't gotten yet. We created a process for doing all this, initially preparing. It really behooves the knowledge elicitation team to bone up on the knowledge domain in which we will create models. It does no good to go in with looking for knowledge domain 101 out of an expert's valuable time. Right? So knowing the basic vernacular of the domain is a very important part of preparation. We can get to an initial scope for what we hope to accomplish. We start the elicitation process, as I just showed on the previous page. We have oftentimes experts' documentation fed into the process. A great many times, and I've done a great many projects of this sort, the expert's talking and he's, wait a minute, and he disappears for a while and he comes out of his office with a book where he or she wants to reference something. So documentation is often an input to the process. Out of this come unrefined concept maps, raw documentation from the expert, and could even be a video of an expert elaborating a point on a particular topic. We refine these resources by rendering them into a form that can be included into a knowledge model. The synthesized resources are the refined resources, an edited video clip, a concept map that has been wordsmithed so that it reads better, et cetera, et cetera. We combine these together to form an emerging model, which is the output of that. We go through a verification, should have listed validation as well, with the expert. This could lead to a modification of scope if we discovered something really important that we really need to address as well. Additional knowledge elicitation, additional resource rendering, additional model rendering, and we basically turn the crank on this until we have a verified knowledge model. I showed you this one very briefly at the beginning of the talk. The purpose of this was created at the Meteorological and Oceanographic Facility at the Pensacola Naval Air Station. It was to take the place of the Forecaster's Handbook. Forecaster's Handbook was a 108-page document that was always out of date and reflected kind of standard military thinking on being able to deal with the weather. You know, hurricanes are really important to the Navy in Pensacola, Florida, if you know anything about our hurricane history. So they wanted to do better by new forecasters that would come to the facility who have to pass a sub-regional forecaster and a forecast duty officer forecaster certification. We elicited the real skinny that they needed to know from expert forecasters who had been there. Things like, for instance, you know when you see the weather radar? That is a NEXRAD radar unit. They are complex machines. How do you set them up to get the best information out of them for some particular facility? We captured substantial expert knowledge about issues like that and many others. This was a knowledge model. This was early work that we did, and really kind of interesting. We were helping to have diagnostic systems for naval electronics technicians. And what we did was to create a knowledge model of the knowledge domain. From that, we culled a rule-based expert system. So you can see over here is an interaction going on with the user. It's asking, test this machine in direct mode, and answer, is it good in direct audio? Does it bad direct audio in one channel? None at all. And the user could answer this question and proceed to a diagnosis, or could ask for an explanation, in which case the user would be transported into the knowledge model that served as the explanatory component of the system. Kind of interesting idea where if we could call the rules from the knowledge model should be sufficient to explain the rules. Uses in knowledge generation are very substantial. I'd point out brainstorming really has a very specific meaning. It is that we elicit uncritically all ideas from a group of people. There is no effort to obtain consensus. There's no particular ruling of that's a pretty boneheaded idea, so why would we include that? You just include every single thing that the group comes up with. Brainstorming is a particular idea that falls under the general notion of ideation, which is generating, developing, communicating ideas, where an idea can be completely broadly construed as visual, concrete, or abstract. Concept mapping has been used for the generation of ideas while simultaneously seeking consensus. I don't know if this link's going to work. I'll give it a try in a moment. This was work that we did in Norfolk Naval Station with Task Force Excel, in which the Navy was trying to figure out the career progression, the career continuum, from recruit to apprentice to journeyman to master for signalmen, quartermasters, and bosun's mates. We had upwards of 20 of the most senior signalmen, quartermasters, and bosun mates in the Navy. These were the top enlisted men in the United States, and they are a very, very argumentative bunch. It's astonishing, and our goal was to seek consensus. So I'll see if this link will work quickly, and if not, I'll just move on. How am I doing for time?
You have still 8 minutes.
8 minutes. Okay, maybe I'm going to cancel this. I think I'll just keep going. Uses for documentation. Due to their concise and potentially unambiguous nature, because they can be written very ambiguously, concept maps can be very good for documentation. An application I would tell you about was work on developing a software security assurance case. And we again had 3 critical participants. In this case, the subject matter expert was the software developer, who of course was quite expert in the software he or she had written. We had a security expert who knew security concerns, but did not necessarily at all know the particular software implementation the developer had produced. And then, of course, we had the driver, which tends to be me, eliciting the concept map on the fly. The product that we created was a knowledge model with concept maps describing the security issues that were addressed, and then links into actual code and documentation that pertain to the software we were assessing. We started with a skeleton concept map, and it had particular vulnerabilities that we were looking for. We wanted to see that error handling vulnerabilities were all there. Essentially, the try catches were around everything that needed to be, that could potentially lead to an exception. We had a transaction log, which was important to the software. We wanted all events logged so that we could recount something if, unfortunately, we ended up back in cybersecurity forensics mode. We wanted embedded authentication not to be there. That basically means you cannot, at the code level, ever put authentication, for instance, to get into a database. You have, and it's interesting, that is a problem because you have to prove a negative. which is an interesting little twist in security. Minimal privileges for proper operation. From that, it took us about an hour to elicit a concept map that looked like this. You will notice that we did document, for instance, error handling vulnerabilities in configuration, which took place in these particular places with a link right back to the code that demonstrated where the configuration took place. We can see where the error logs were for display of errors and etc. So you can see that we actually could elicit an account of how we were addressing all of these security concerns while linking right back to documentation that either required it or illustrated that it was addressed. This is some separate work also that I did on documenting service-oriented architecture applications. And I've created Carrot, a composite application reverse engineering tool. This takes as input BPEL files, business process execution language. It's a fundamental way of describing. It's interesting. For those of you who like computer programming, BPEL is a general purpose computer programming language rendered in XML. It's pretty much unusable outside of an editor that enables you to draw pictures of the program you want to run. But BPELs are an underlying important part of service-oriented architecture composite applications. WSDL is web service description language. It is a way of describing service. It exposes service interfaces is the best way to put it. So WSDLs allow you to say, I want to use a web service. What are the services available? WSDL describes the services themselves and the parameters that are required to call them. XML schema is for defining data types. And these three technologies underlie service-oriented architectures and are very important. Carrot takes these things, munges them all together, and produces triples. You remember concept, linking phrase concept, what I talked about right at the very beginning? That is a triple. Carrot takes these as input and then produces triples, which can be imported into this tool I'll tell you about just in a moment. Actually, CMap Tools is the tool that was used for all of the concept maps you have seen. The triples are imported there. Auto layout gets a rough layout of it, and then a person can just refine it from there. The basic knowledge model can be augmented, again, with expert knowledge elicitation. So an example of this was, this is one of several that I have in a paper. A BPEL-based composite application had 48 separate procedures that could be called. I think we needed 6 or 7 in this particular composite application. We'll see that in a moment. And it also had internal and external XML schemas. The interface looks like that. And the result was this concept map. All of these concepts and links were automatically created from triples produced by Carrot. And we can see here this was an order processing thing that needed to get attributes, and it used an interface at Amazon SimpleDB. It needed to be able to put attributes. It got a US tax rate that was defined in this particular procedure interface. It could send a message from this particular interface. It could get a UPS postal service rate using UPS WSDL. So the interesting thing about this was it used both BPELs that we had defined with services that were out in the world, and we were able to reconstruct the entire composite application automatically generating triples with Carrot. We can also use them to create knowledge formalisms. Concept maps, as I said, are completely free-form. We hope we have triples instead of quintuples. An example, grass is green would be a triple, stands by itself, makes perfect sense. What if I said, grass is green in summer? That is a quintuple. You'll notice green in summer doesn't really convey any meaning. Does that make sense? You need the grass. You need to know that you're talking about grass to know for green and summer to make any sense. We call maps that have all triples independently readable on their own propositionally coherent. And given a propositionally coherent concept map plus some automated and manual techniques, we can create knowledge formalisms from this. If we have, oh, and we were talking about they may be unambiguous. If we have quintuples, all bets are off. Using these, though, we had actually two projects. At IMCIC, we had the co-project, which created capability to produce OWL ontologies. This is Web Ontology Language. It's a pretty bad acronym, right, because it's not in the right order of the words you need. Web Ontology Language ontologies is one of the representations underlying the semantic web. And we could produce OWL ontologies from concept maps so long as they were written in triples. They'd come out incoherent if they were written in quintuples. We could also create concept maps from OWL ontologies. We also could create formalisms manually by synthesizing knowledge from several concept maps. We did work on a large-scale healthcare provider. They have this extraordinary need for a consistent data definition, and they had none. We looked at a provider, and we boiled out that properties of providers are, for instance, their role, could be any of these, their location, demographics pertain to all of these sorts of things. Are they in network, yes or no? Their identity, the type of thing that are they an individual or group, et cetera, et cetera, et cetera. So this data all started in concept maps, but we were able to create essentially a formal structuring of knowledge from the concept maps. So I've discussed the use of concept maps and knowledge models for a variety of uses, including educational, for the capture and preservation of knowledge, a use in knowledge generation. We can document things with them. We can generate knowledge formalisms from them. Right? A very, very versatile tool that cuts across disciplines to the degree that we can define them. And CMAP tools was used for all of the examples I've given you, and it is freely available at www.ihmc.us.
Thank you so much.
And that's...
The knowledge map that you showed, right? Like, is that the final output or is that an input? Like, are you trying to enter some data and then like the knowledge map, whatever that you showed, that comes out as an output of that particular software?
Good question, but which one are you referring to? The last one or one of the earlier ones?
If you can, yeah, something like this.
This. Well, this could actually be produced into triples by exporting out of CMAP again. And if there were some sort of translation program that created data definitions, this could be an input to that in order, for instance, to generate, it would be a relatively simple compiler issue to write a program generator that would generate Java code from this, for instance.
So this one was, this is where like you sat with the subject matter expert and the engineer.
Yes. Mm-hmm.
So this is the one that you're talking about. It's a pre-pro form that you have to put it into the tool, right?
Yes.
Okay.
Yeah. Well, now this one started with concept maps, which we manually boiled out. Okay, these are very general properties of a provider. These are some of the roles they might play. That was all there, and we manually organized this one. This was not an automatically generated map. From here, we could automatically generate data definitions, though, in a variety of different languages.
One more question. Is there any tool around this? If I feed a bunch of code into the tool, it will create like a concept map like this. Is there anything like that? Because I saw somewhere you were telling about a reverse engineering tool.
This one, There is a tool for this, but it is particular to parsing and analyzing WSDL's, BPEL's XML schemas.